Today we're going to discuss how to solve some equations, specifically one-step equations, the most basic of equations. And in order to get started, we've got to talk about properties of equality. So here I have, for the four operations, each property of equality. And it basically states that if you have an equation and you add something to both sides of an equation, the result is the same. Or if you have an equation that's true and you subtract the same term from both sides of the equation, you have a true equation. If you have the same equation and you multiply the same number to both sides of the equation, then you have a true statement. And lastly, if you divide the same thing to both sides of an equation that was true, you still have another true statement. Just take a look over these. You don't need to write them all down, but you need to understand the concept. Basically, what it's saying, in order to keep an equation balanced or true, you have to do the same thing to both sides of an equation. So, this is kind of key. Let's take and start solving some of these. In order to solve an equation, our goal is going to be to isolate the unknown variable or get the variable by itself. So we know that a variable is just a letter or a symbol used to describe a number. So in each case, we're going to find out what this variable is equal to. Now, what we want to do is we want to isolate this variable, and right now it has an addition of 5 with it. So to undo an addition of 5, or to get rid of that, I have to do the opposite operation of this addition of 5, which we know is subtract. So what I'm going to do is subtract 5 from both sides of the equation. 5 minus 5 goes away, leaving me with n, and 21 minus 5 we know is 16. So I've solved my one-step equation. In this equation, we have a subtraction of 7. To undo a subtraction of 7, or to get the 7 away from the left side of the equation and get n by itself, I have to undo a subtraction of 7 by adding 7 to both sides. 7 minus 7 goes to 0, so I have n on this side, and I have 26 and 7, or 33 on this side. So once again, I've solved the equation. Now, if we talk about negative numbers, there's a couple of ways to do this. We can, since this is adding, subtract a negative 15, but I prefer to rewrite the equation. I know an addition of negative 15 is the same as subtracting 15. So I've rewritten the equation. And I know to undo a subtraction of 15, I add 15 to both sides of the equation. So in this case, I have n equaling 23. Now in this equation, I'm subtracting a negative number. I'm going to rewrite this. I like to think of subtracting sometimes as adding the opposite. And in this case, if I add the opposite, I really have x plus 20 is equal to 7. So if I want to undo an addition of 20, I subtract a 20. So you'll notice now I have x equals 7 minus 20. Well, again, subtraction, we can think of that as adding the opposite. So I add the opposite of 20, and I end up with negative 13. Because 20 carries the negative sign, I keep the negative and subtract the two numbers, 20 minus 7. In this case here, we have a subtraction of 16. I'm going to add 16 to both sides. So what I have is I have x equaling positive 16, negative 12 if you will. I keep the sign of the bigger number, which is a 16, so that's a positive, and I subtract the two numbers, giving me a 4. In this case, I'm adding a negative 8. I like to think of it once again as subtracting an 8. So I'm rewriting the equation, and now I will do the opposite of subtracting 8, or add 8 to both sides. So in this case, I have a negative 61 and a positive 8. I keep the sign of the bigger number, which is a negative, and then I subtract the two numbers. So 61 minus 8 is negative 53. We're also going to have to deal with fractions. So in this case, since I have a mixed number, I'm going to change that to an improper fraction. It gives me 6/8 over 3 plus x. Now in order to get rid of 8/3 plus x, this is a positive, so I'm going to have to undo it with a negative, or subtract an 8/3 to both sides. This gives me an x on this side, and now I prefer to write these in a horizontal position. I have 5/6 minus 8/3. I get common denominators, so I have 5/6. Notice in order to make this a 6th, I'm going to have to multiply both the top and bottom by 2. So in doing so, that's going to get me a 16. Now, notice this is a number subtracted by a bigger number. I prefer to say this is the same as 5/6 plus a negative 16 over 6. So then I take the sign of the bigger number, which is 16, and that's negative, and I subtract 16 from 16 from 5, getting me 11 over 6, and my answer is negative 11/6. Moving on to multiplication. In order to undo a multiplication, I can either do a division or multiply by the reciprocal, and I think I'm going to prefer to multiply by the reciprocal in this case. So if I take 3 times x and I want to undo the multiplication of 3, I can multiply by 1/3 to both sides. Notice, this is like 3 over 1. If I multiply that to 1/3, that gets me a 1x, which is what I want, and 27 times 1/3 is 9. In this case, I have a division of 8. Undoing it, I'll multiply by 8 over 1, so then I reduce to 1x. But if I multiply by 8 over 1 to one side, I must multiply by 8 over 1 to the other side. And remember, this negative 4 is like negative 4 over 1. So when I multiply negative 4 by positive 8, I get negative 32. Here I have a multiplication of negative 6 to the x, and I want to undo that. So I can multiply by its reciprocal. But if I want to make it positive, I have to have a negative 1/6. So I get a positive 1x here. I'm going to multiply this side by a negative 1/6. This gets me a negative 30 over 6. So therefore, x equals, after reducing, negative 5. In this case, I want to get x by itself. I'm going to multiply by the reciprocal, so I get 1x. So 2 over 5 times 5 over 2 gets me a 1x. and I have to do to the other side the exact same, and I'll put that negative 7 over 1. So when multiplying fractions, we multiply the numerators together, giving me a negative 14 over 5. We notice that, again, we have an improper fraction. I'm going to change that. This is 4 times 1, which is 4, plus 3 is 7. So I have negative 7 over 4 times x. And in order to undo this multiplication of negative 7/4, I multiply by 4/7. And since it's negative times a positive, that would give me a negative x. But I have to multiply by a negative 4/7. So I get a negative times a negative is a positive. And then once again, whatever I do to one side, I must do to the other. So I'll multiply 5, and that's 5 over 1, to negative 4/7. I get 1x is equal to negative 20 over 7. Now keep in mind, we need to make sure all of these are correct. We should probably check these from time to time to see if this works out. So let's do that. If I have 5 equaling negative 7 over 4x, and I know that x is equal to negative 20 over 7, then 5 should equal negative 7 over 4 times negative 20 over 7. Notice the 7's will reduce, the 4 and the 20 reduce, and I have a negative times a negative, which is a positive, so 5 equals 5, and the problem checks out. You can always make sure your answer's right by going back and checking. So now let's do a word problem. We've got Mr. Hill's farm is 126 acres, and then it tells us that Mr. Hill's farm is a quarter of the size of Mr. Miller's farm. And we want to know, how many acres is Mr. Miller's farm? Well, let's write an equation for this statement. Mr. Hill's farm, Hill, is equal to, is 1/4 of, that means multiply, Mr. Miller's farm. This is a relationship that I have, but they tell me that Mr. Hill's farm is 126 acres. So I know that this H value is 126. So I'm going to say 126 is equal to 1/4 times m. And now I would need to isolate that m. In order to make this 1m, I must multiply by the reciprocal of 1/4, which is 4, to both sides of the equation. So multiplying 126 by 4, I'm going to get a total of 504. And that's going to equal the size of Mr. Miller's farm. And let's go with units, acres.